Well, hi and welcome to my shop. Today is June 6th. So before I get going on the radio here, June 6th is a very, very special day for me. It's the anniversary of D-Day. And this is important to me because my father not only was involved in D-Day as a Canadian soldier, he landed in the very first boats. On the Canadian Juno beach, there were 10 boats landing at once, about a football field apart. Let me just picture that for a minute. There you are in a boat, and you look left or right across a football field to see the next boat. Pretty lonely affair. 40 men in a boat, 400 altogether onto the beach. Obviously, my father survived the war because I'm here. But where he landed, and the boat immediately left of him, virtually every soldier was shot dead by a machine gunner. And the beach he landed on, the men he landed with, suffered the highest casualty rate. In comparison to the Omaha beach, which is the beach we hear most about, similar, more, a little less, I'm not exactly sure, but certainly in that realm. I think it was something like 40% casualty rate crossing the beach, something like that. I'm not sure. Well, that was my dad, right there on D-Day. My dad never talked about it. I asked him a few questions when I was a kid, of course, because I knew he was in the war. He was a soldier, but he didn't tell me a thing. And then along came this book in the 90s, written by this guy, Charlie Martin. This is a well-known book in Canadian military circles. It's a battle diary. It's the soldier's description of what he did after landing on D-Day. My dad and this soldier were fighting together. That's my dad right there. And that's the writer of the book. So by reading this book, I learned a lot about my dad's experience. It says there, Lindy Lindeness on the right and myself, likely around the time we were sharing a slit trench in Greatzville, somewhere in France. So every year I like to do a little something on this day on my video, to commemorate my dad, and I was having a hard time thinking about what to do this year, and I decided I'm going to talk about anti-fascism just for a few minutes. And the reason for this is because I have a lot of American viewers. You might be American. And Americans talk a lot about anti-fascism. They use the term antifa. And I can only be very frank here. I'm not going to bother holding back. There's a propaganda move going on with that term, antifa, led by the past president, who has suggested things like Antifa is the cause of social disruptions in the States and other things like that, and Antifa is an organization that should be declared a terrorist organization. The president had talked about that kind of thing. He regularly brought up Antifa as, an organization that's causing a lot of problems. So I'm going to talk about Antifa because my father was an Antifa fighter, anti-fascist fighter. And you're going to hear some anger in my voice as I get into this. I'm not going to be able to hold it back. So Britain, Canada, Australia, United States, other countries joining together to fight fascism. To fight fascism in Europe and elsewhere. And my dad has a 19-year-old landing on a beach shooting fascists. That's what he was doing. An anti-fascist fighter. An Antifa fighter. If you look at journalism, journalists who write about Antifa, when they write the word Antifa, they don't capitalize it. Why? Why wouldn't they put a capital on the word Antifa? Let's talk about Antifa as an organization for a moment. If you're American, I'd really like you to listen to this, because you might have been propagandized to the point where you believe nonsense. Antifa. Where's the headquarters? Who's the leader? Where's their publications? Where's the membership list? Where's the bylaws? Where do they meet? Antifa doesn't exist as an organization. It never has. Antifa is a contraction of the two words anti-fascist. And I'm proud to say that my father was an Antifa fighter, along with many Americans, British and others. And if you're an American and you've listened to the bullshit that comes out of your past president's mouth, and you now think Antifa is something to deal with, what's happening to you is you are being turned into a Nazi. You are being turned against those who fight fascism. You are being turned into a fascist. If you think Antifa is an organization that needs to be dealt with, you are already well down the road to being a Nazi fascist. The person and the people that my father and others fought against. Right? Okay. Now, I knew this was going to happen when I brought this up because I have so much anger in me over this exact issue. Time and time and time again, I have heard Americans talk about fascist or Antifa as if it's an organization, and it is not. Antifa fighters who show up on the street are individuals who spontaneously step forward to fight against what they know in their hearts is evil. And it's been like this for 100 years. When fascism raises its head, spontaneously, people will fight it. Individuals, unorganized, will fight it. To fight against them is to fight in favor of Nazism. Dad, I'm doing my best, okay? You fought that fight. You pretty much ruined your life. The rest of your life got ruined by that war. And I'm trying to do something here with my little audience to try to realize, support, or protect what it is you did with your life while others trash it. Okay, so I can take a little break now and calm down, and we'll get started on the radio. Okay, calm myself down now. First, I want to thank Keith for sending me this. This, of course, is the layout of the board here. And Keith found this, or got this, from Radio Museum. The odd thing is, I'm a member of Radio Museum. I couldn't find this in Radio Museum. The schematic I'm using came from Radio Museum. If you're into doing this kind of stuff, fixing radios like this, you should be a member. I think it's just a one-time cost. Pay it once, then you have full access to all their data, including stuff you don't even know about, like this. I didn't even know this. Well, anyway. So, does this exactly match this? This is the 813E. This was for export. This is the 813 not E. I got 813 written there. So this could be different. So let's make a few comparisons. Let's make a few comparisons here. I'm just going to change the lighting a bit. Just a little easier. A little bit easier. Okay, I'm going to look right in here. Okay, we see this. This guy here is this. Capacitors right there. There's a wire coming out of a board right there. It's matching perfectly. The wire going over to here. There's the can. Two tubes. A wire bond here. Oh, two resistors here, but there's only one. So these two are in parallel. These two are in parallel. Oh, that's a resistor and a capacitor. What's happening here? Well, there's a real ugly capacitor right back here. 47. Let me just set my cameras up a little bit differently here. Okay, let's try this arrangement here. Looks like it's just a wee bit out of focus still. Maybe I move the camera a little bit. There we are. Interestingly enough, this piece of paper is just about exactly the same dimension as the board itself. So it really should be easy to line this stuff up. So we were looking in this area, which is this area, and it's just this one capacitor, resistor. I'm never too sure when they look like that. So just above it here is one of these brown capacitors, 47 nanofarad. That's got to be this brown one here. So what's happened to this capacitor? I don't know. Maybe it's underneath the board. I don't know. There's only like two holes here for one device. So small difference. Why, we don't know. Let's keep looking around here. So if we come towards the back, 56k ohm large resistor right there, right here. There's a couple of these capacitors that are kind of standing up vertical. There they are, two there. Yeah, matches up. We have a resistor across here. I'm just quickly going back and forth. It looks a little different. This blue piece doesn't seem to be here. Okay, let's start down in this area. This is the area I was interested in. 50 microfarad, there he is. Put him in. 220 ohms. I thought it was 200. This is 220 here. There he is, 200. Another resistor here. We have a capacitor matching up perfectly. I don't know if you can see all this at the same time. You can't, can you? This isn't coming through all that well. Too much light on it. Trust me when I say it's all matching up. Let's go in this area here. 5 microfarad. Oh, I didn't really see that right there. 5 microfarad electrolytic. That's probably part of the FM detector. Very important one to make sure this is in good shape. So we'll replace that for sure. I'm going to come up in this area. See it. Capacitor here, capacitor there, and well, there's two here. So I noticed this earlier at a quick look. There is a difference here. My camera, what's happened to my camera? Oh my god. There's a difference here. So if we look, just looking for something to point with here. If we look at this one, this is this really chewed up, egregious one here. And you can see there are two capacitors here, but on the diagram only one is shown. Shows there's a resistor here and a resistor here. Shows only one resistor. This capacitor is connected. There are two terminals. A terminal here, which is shown, and a terminal here. There's another capacitor connected between these terminals here, which is not shown. And then there's a resistor from this terminal, not shown, over to this terminal. That resistor right there. See how it's kind of, look at these. This is up on top. This is up on top. It's kind of interesting. They're not laid down on the board. This must have been later thinking that they had to add this. There's a red wire here too, coming from the same terminal. Don't think they show wires on here at all. The red wire is heading, oh, it's heading way up here. Way up here. So even though there's some component variations, it would probably, the components that are in there match this. So this is probably a 10. And this is probably a 2.7 nanofarad. And then this we don't know, but maybe this one's good enough we can read it. And we don't know why they did this. Yeah, we don't know. Could just be a little bit of an improvement. So maybe between the time they made these for the European market and then they started making them for export, maybe on the export model they made these small improvements. Use all the same boards, everything the same, but a couple little improvements the engineers wanted to make. So this is what we're seeing here, is an improvement. What else is different over here? They have the A, B, C. I wonder what that is. So there are terminals here, A, B, C. So these are probably test points. Okay, we got a really old one over here. That one, 10 nanofarads. Now what about these? Maybe we can figure out these ones. So these are not on here. I didn't put these on here. But they're in relatively good shape. I can probably read the value off them as I do them. Okay, so what did we find out here? We found out this is pretty darn good, but just a few minor changes. Need to look carefully at it before relying on it. And we found out this is supposed to be 220, not 200, but that's okay. I'm not going to worry about that. At least not right now. We got the value for this and that. We got the value, yeah, we're good. Much better off. So maybe I'll leave these alone up here. Go after the ones I know now. Because maybe, hey, maybe someone's going to send me more stuff. Good. Okay, first clump. First clump. I have to decide which clump to do here. Clump. Yeah, I'm saying clump, so I guess it's a clump. Got a clump of these. We're going to go right in there and do that. In there and do that. So just in case you hear different levels of background noise when I'm going from segment to segment here, that's probably my house air conditioner, whether it's on or off. It's on right now, so I'm pretty sure you can hear it a bit. Yes, air conditioning in the morning, that tells you something. Yesterday temperature got to 30 here. It's going to get up to 33 here today, 32. Very hot and very high humidity. So, okay, I realized that with this chart, I can track down where these components are on the schematic. So we're going to look at the schematic and we're going to find which capacitor it is that was supposed to block the grid to this tube, because I think that capacitor, and it's probably one of these, I think it's interesting to know which one it is. Let's take a look at the schematic here. Okay, so we look right here. You see a 1K resistor. Now, I'd like to talk about that resistor for a moment. Not to be confused with the 1 million ohm resistor here. This little 1K resistor is probably here to stop oscillations. I could be wrong about that, but I believe that's what it's doing. And the last radio I was working on, oscillations were king in that thing. It still are, apparently. And one of the things I didn't mention during all those videos was I was interested in these kind of resistors sit in that radio too. Anyway, not to talk about that one. That's probably what this resistor is doing though. And this would be the blocker here. 10 nanofarad, number 253, blocking the high voltage that's over here. Yeah, 253. So we'll look at the other diagram. We can do it right here actually. Say 250, there it is. You know what? It's that super chewed up capacitor. It's just exactly the one I was suspicious of. Huh. There's the 1 million. There's the 1K. That'd be the grid. Now why don't we find out what this guy's doing? He's number 261. 261. 261. There he is. Involved with the screen circuit. Kind of a funny arrangement there. Box. Okay, but that's not going to be responsible for the burned up resistor. And the burned up resistor, it definitely says 200 here. 256, and it's bypassed by a 50, yeah. 257, so 256, 257. 256, 257, there they are. Now what's this guy? He's number 247. Look for 247. This is the one I think is part of the FM detector. Now where would that be? So the FM detector is going to be involved. Somewhere. What I'm looking for is like a separate coil. I don't see one here. Okay, I'm not gonna be able to sort this out maybe. So here we are coming last IF. We have, I'm gonna guess this is the FM here. And a signal coming down to this mass of switches. Funny business over here, probably all oscillator stuff. Well, I can't see it. I'm looking for a coil that's used to demodulate the FM. So where's that resistor? Where's that capacitor rather? What was the number again? Number is 242. Number 242. 242. 333. There it is, 242. Looks like 5 microfarads. It looks like. Use the plates are colored like this to indicate it's polarized, it's electrolytic. It's the bypass. Oh, I'm wrong about what it is. It's the bypass on a cathode resistor. So how... There is FM in this radio, isn't there? Am I crazy? I'm sure I saw FM in here. Sure there is. Well, I don't know how they're getting the audio out of the FM signal here exactly, but no doubt they do it somehow. So that I'd still be looking for another electrolytic capacitor. It's not Not that it has to be electrolytic, it has to be fairly large, and the best way to do it is electrolytic. Yeah. So audio, we work back from the audio. Yeah. Somewhere in here, somewhere in this area here is the thing I'm looking for. Okay. Good enough though. Bit by bit. It's coming clearer and clearer. Well, I'm going to pop this capacitor off the top. This one's not listed or shown anywhere. And I'm going to look at it. I'm going to take this out here. Schematic shows there's terminals on the board here with nothing connected to it. Why would they put terminals in? In some radios, I think they come off the end of the assembly line. I know for sure this is the case. They come off the end of the assembly line and they may cut components free. The little transistor radios have this happen a little bit. They find out that they put in an extra component just in case things work out a certain way. And when they work out not that way, they work out more normally, they cut the component. They just cut the wire and leave it in there. I gotta look at this with a close-up camera here for sure. It's gonna be out of focus, something terrible. Just bear with me a second here while I figure out what I'm doing. My little speech at the beginning of this video has really left me quite disturbed. Ooh, that's really close. Thousand volts. Oh my gosh. There it is. Something picofarad. Man, I'm gonna put this down. 1,000 picofarad, 1,000 volts. Is that what that is? Thousand picofarad is 1 nanofarad, 0.001. 1,000 volts. And apparently, 1,000 volts not enough. Look at this stuff coming out the side. Oh gosh. These things really get ugly looking, don't they? What's the name of it? Wimma. Okay, well I think we can be pretty sure that's 1,000 picofarads there. Good. Now I think I'd be smart to go ahead and change this one out before sticking. Change all these out in order. I'm actually cutting them out the wrong way. Let's cut this one out next. Let's cut them out of there. Free the capacitors. I'm leaving the wire tail so I can connect to it. I don't want to break this up too much more than it is already. Oh my gosh. Look at this. Something's happened underneath. Oh, I didn't like that sound. What was that? I did not like that sound. Okay, don't worry about it right now. So I'll get my hand on that capacitor. It's just, oh gosh, you can see exactly what's happened in there. Let me switch cameras here. Wait, I'm not thinking as, as I'm thinking even more crooked than I usually think. Oh boy. Okay, let me get my finger on it. Okay. Anything moving? Wow. So one of the reasons I'm avoiding replacing components down through the board here is because when you push the lead of the new component down through the board, you can pop this off so easily. And things go downhill from there. Once you've popped one of these loose, it gets a little messy, a little hairy under there. So it didn't actually break it right off though, did it? But that was loose on its own. Hey, there's another one moving. Just that one. No, wait, what's moving here? There's a spider web that's moving. Let me clean it off with my finger there. There's that cut trace. There's the moving thing. Yeah. Oh! It's still hooked up with a spider web. So now this may have come extra loose because the capacitor appears to have overheated, although frankly I don't know why. You see that little break? I've mentioned this before. This could be a spot that under certain circumstances they would solder over that break. And, what those circumstances would be, I don't know. But okay. Best thing I can do is cut it free at the top still. If I can get at it. It's really not very friendly to my cutters here. Not much cutter space. And here it is. Get a good look at this. At this piece of, I don't know what to call it. The most egregious capacitor I've ever found. Wow. I really don't have any explanation for why it would look like this. Wow, this must have been maybe this was a bubbly, steamy mess or something. I mean, how do you get these? How do these even get hot? If you have bad, I mean, they're not big enough to, I think, get heated through dielectric effects. I just don't think there's enough there. But if you have a straight leak, like moisture leak through it, well, I guess if it's bad enough. But boy, you need a lot of moisture to really. The thing about moisture too is it dries itself out. What a schmozzle. Now can we read anything on here? Just the maker's name. No, I don't think we can read any values out of that. Luckily, this one's on the schematic, though. Okay, just looking where it came from. The components that are left behind, they don't look damaged at all. Even the good one is bad. If you can call any of these good. Okay, I'll cut that last one out. You get the impression I'm kind of taking my time. I am. I'm not rushing at this. Okay, we'll try and... I'm going to get that other side. This one I might have to desolder. Pretty awkward in there. That's what I'm going to do with that. So I'm going to melt it, pull it up through, and then start putting the new ones in. Okay, that's a bit of a curious little arrangement here with these two guys kind of floating out here. There's a terminal. This is really kind of weird. So these two are tied together at the top onto this terminal. The terminal's not connected to anything. What's going on there? There's a mystery after mystery here. So again, generally they don't engineer stuff to be floating around like this. Oh, look at that crack through that thing. Kapowie. So there's the, you can see what they've done. That's really weird. That's just a floating piece of metal out in the middle of nowhere. What could it possibly have come off of? Because, I mean, it can't go anywhere. Does it have a hole in the bottom? Ooh, looks like it was stuck on something, doesn't it? It has some solder on it. This is pretty darn weird. Now, like, what's going on? These wires here, did they yank it off something? This is pretty solid. Why would they do that? Wouldn't they just solder the wires together up here at the top? Why bring them down to a terminal? It sure seems to be headed somewhere. Let's see, is there other terminals that look like this terminal? Like in this switch here. That's what that one looks like. That's pretty weird. Got a rivet hole, like a rivet holding it. Well, there's no rivet hole in this one. You know, a typical thing would be for that to be grounded. That bracket back there. Why wouldn't they solder it right to the bracket? Why to a terminal? Can I see a missing? Can I see something is broken off here or missing? I really can't spot anything. That's just a mystery. Petrick. Who's he? Yeah, subcontractor bending these metal parts, stamping out these metal parts. Well, and then you have these two. Look at their 1,000-volt capacitors. They use 1,000-volt capacitors everywhere in here. Oh no, 250-volt. 1,000-volt must be like 1,000-volt withstands a rush, or or a shot of 1,000 volts. It also mean 1,000 volts DC, 250 AC. Looks like 250 AC with a B and a minus slash. I have no idea what any of that stuff means. Why wouldn't they just take one capacitor and tie it across? Why use two with the thing in the middle? That's tied to nothing. This just doesn't make any sense here at all. What if this thing got bent way out? It's way over here somewhere that it's supposed to be. How far away could it go? It can't barely make it to this surface. Could make it maybe down to the board. Oh, look at those solder. Look at that. Wow. Now look, on either side are two pins coming through, not soldered to anything. You know what I'm wowing about? I'm wowing about the fact that that is broken. Now I'm going to reach around and try to figure out what that is. Okay, hold still. I'm just wiggling different things down in that area. what's down there. So we're almost in the corner, right in the corner of the board. So we come from the corner, in and over. Look at the one above it is cracked. That's cracked too. These are all cracked. Everything's cracked. Look at. Wow. Okay, so boy, if those are cracked, the cracks could be anywhere. Let me look and see what's down there. You find cracked solder things where there's mechanical action happening. So, you know, volume controls and things that are being manipulated. So we're looking right. Oh, it's the tube socket. The tube socket. What's in, so you know it's the heat story coming through again. Tube running too much current, getting too hot. Heat coming down through the pins into the socket. But look at the socket, does look like it took a little heat. The heat traveling right through, warming up the solder, and the result is the solder goes through a chemical change, crystallizes more, and then cracks on the grain boundaries, and then you get what we saw. Grain boundaries. So that's where the contaminants in the metal will be squeezed or worked out of the main metal crystal to the edge or surface of the metal crystal where it meets the surface of another metal crystal bumped up against it. And that interfacial zone gets full of contaminants that were in the metal, and eventually the metallic adherence disappears, if it ever was there, really, at the crystal boundary, and it just becomes weaker and weaker until finally it just separate. There's no mechanical strength to it. That's what's happened there. That's aging. Lead or other metals that melt at relatively low temperatures are chemically active at room temperature and a little bit above. Stuff's happening to them. Well, that just looked like a huge resoldering job, not much more than that, really. Just the heat in the, can you see the heat in the board? So I'm looking with my own eyes here, not really. The board is dark brown to begin with. Let me look underneath it again. Because what we want to know is this effect just in this little area of the board, or is it all over the place? So, well, let me use the other camera briefly here. So what we're looking for is like a dark area in the board where the color, you know what? This is darker. This is darker than here. This looks almost black. This looks just very dark brown. You probably can't see it really in the camera. Not really. You can kind of tell that this is different down here. So a lot of heat buildup down in this area, and it's affected a number of things. Capacitors, everything. Yeah. And most importantly, the solder stuff there. Which, where I'm standing now, I'm looking at it from a normal distance, just looking at it with my eyes. I would never know there's cracked things there. You need like a microscopic or magnified view to see that stuff. Okay, something to keep an eye open for as I carry on with what I'm doing. Yeah, I'm sorry, I was going to solder, I was going to loosen that off with the soldering iron and pull the capacitor out, and that's, might as well just do that right now. Let me do that. Get a grip on the capacitor here. Easier said than done. What's this terminal right here? Melt, melt, melt. find this. There, I got it. I didn't really yank on it. Often when the component's installed, and you would do this too, the wire comes through the hole, you tend to bend it over, solder it, and then cut it, or cut it and then solder it. And in case you bent it over, pulling that back out, even if it's cut really close, can be really tough. See a little hook in there? Yeah, so pulling it out is not as easy as you might think. Oh, this one we can read. Another 1000 volts, 1000 and 500 are the two rating. 250. What? What? Come on, what is this? Rated everything? So see, 330. Oh, looks like 3,300 picofarad. 3,300 picofarad. 1000 volt, 500 volt, 250 volts. Well, which one is it? Come on, how can I have all these ratings? 108. Is that the temperature? 108 C? That's weird. That's weird too. 250 volts, got the alternating current thing there with a B. And then 500 volts alternating. What are they trying to say? There's 250 volts floating, like AC floating on top of something? Is that what they're trying to say there? 500 volts DC, or that's it. No, 500 volts AC. 1000 volts must be DC. There's too many ratings on here. Too much to read on this little guy. He's not in the worst shape. Hey, why don't we test this? Let's test this one. I could test them all really and find out what they show up as. Kind of cut the leads right off. This one here. Are we seeing the metal right inside there? I think we are. Yeah. See the shiny copper shining back from right inside the divots there. Hey, let's test these capacitors. You know, to a large degree, this is all about having fun and you know, learning as you go. Certainly, my channel, I'm not demonstrating my prowess. Where are we here? So I watch a lot of videos on guitar playing. I see people who play guitar a little like me, not all that well. But then there's these people who are real musicians who understand music way beyond my understanding of it. These guys come out, they show you stuff. It is so intimidating, and I sort of convince myself I can't do it even before I try. Yeah, the fact is I can't do it. But I won't even try. I'm so intimidated. Didn't I turn this on? I did not. I did this stupid move. That was a dumb move. So I think if I edited my videos so I look like a genius, it wouldn't be hard to do. Actually, in my case, it might be hard to do. But I could hide all my faults easily. I think that's the natural thing to do, is to hide all your faults. Then it'd make videos which wouldn't encourage people to do this. And I'm trying to, you know, without really saying it, I'm trying to encourage people to take a shot at this. Okay, take a shot at this. 50 volts onto this junk capacitor, watching the eye for its action. Yeah, it's not coming open. Holy smokes. That definitely is. It looks like it's shorted. I wonder if it is. Well, we can measure the resistance with this guy, which I never do. Let's try it. So, I'm going to measure the resistance. The way we do this, you swing this dial until the eye pops open. Oh, it's doing it down here at the end. That's no good. So I have the feeling that this is a very high resistance. Yeah, we can't trust the readings down at the very end. I think it's extremely high resistance. I don't think it's... Yeah, let's keep going with this experiment. So this would strike me to be an absolutely horrible capacitor. See if we can figure that out with this tester. So this guy should just try to read the capacitance of this thing. How much you want to bet it can't even relate to what this is. Let's see. Whoops. Let's see. Oh, I just push buttons on my computer here. Okay, so it thinks it's a capacitor. It thinks it's 15 nanofarads. It's supposed to be 10. So that's not far off from 10. But the thing is, when the capacitor reads more than what it's supposed to be, it's usually because these instruments are being fooled by leaks in the capacitor. That's my impression, though. This instrument, this is a very different, this guy's very different from classic testing instruments, so I don't know what to say about that. Interesting, it didn't just, oh, let's try another one. Let's try one that's in fairly good shape. This one's in good shape. 3000. Try reading the capacitance here. Well, I guess we better check it for its how leaky it is first. Okay, 50 volts. Yeah, popped open. So this one doesn't look so bad. It seems to be okay. Let's give it a couple hundred volts here. Okay, a couple hundred volts. It's not opening the eye. Brand new capacitor will open the eye at the highest setting, like that. So there's some amount of leakage in here. It's kind of a quality test. We can probably try reading the capacitance. It's probably a very small one. Okay, we move the control to where the eye pops open. Not at the end here though. That's not terribly reliable. I don't think we're going to be able to read it. Oh, here's a spot. Now you can't see anything happening on the camera. I just can't make it good enough to show you. There's something going on right in there. But it doesn't open the eye. It just makes it change a bit right here. So if that were it, this would be 0.001, 0.005 if this were reading correctly. And this is a I don't remember. 005. What's that? 001? Is that what it was? No, this should be a 003 on that test. Yeah, I mean, look at it, crying out loud. Well, I'm going to save that and put it in another radio down the road. No, I certainly won't do that. Okay, have we kind of run the whole gambit here? Yeah, capacitors are out. I got to start putting them in. Okay, so that's the those three done, and I think I'm going to go after these three guys up here next, and then think about probably doing some more before I turn it on. So, okay, these three next up here. Okay, those guys are in. It's really pretty tricky doing these. So I've got this electrolytic. I've got two more little brown ones here. Then I think that's it for the top. I think that's it for the top. There's a couple in the bottom. Actually don't look that bad. What about over here? Nope. Okay, just a couple more back in here. So these two capacitors I decided to replace through the board since it's quite open here. So what I've done is I've hooked one end of the capacitor with this tool so I can pull it out or pull on it, and then all I got to do is just melt the solder on the other end. And where is the other end? So I think like anybody I have trouble identifying exactly where the other end might be. It's possible it's this. that's the lowest row of contacts. The lowest row of contacts. The lowest row is down in there. Oh my gosh, it's right into these terminal things here. Uh-oh. I was hoping it just comes up into a regular solder pad, but it looks like it's coming into these. Feels lower. Feels like it's under here, which isn't. That's not what you would expect, eh? The other end of the capacitor is up in here somewhere. It's that one. Let's see if I can pull on that. Sure feels like it. Ooh, that feels like it too. Either one. They all feel like it. Nope. That's inside the can. This is just outside here. I'm really having trouble. Even if I manage to heat it up, it won't necessarily pull through easily. This can't be it, can it? Boy. I think I'm doing this the easier way, and I don't know now. We'll do it with some X-ray light here. See if we can see it through the board. Problem is I'm on the wrong side here. So the capacitor is right here. It's quite clear where it's connected. Okay, let's keep the light like that. Ooh, that's not the right part. This is this is the right part over here. Right into there. Does not want to come out. Okay. No other terminal really. Okay, I'll start pulling the other end out. wires are bent over just enough to make it not easy. Should not use your soldering iron as a tool. Come on out of there. Got it. Get a better grip on it to get it out from down here. As soon as it cools off a bit. There it is. Small one. 1000 picofarad, 500 volts. So it's a 0.001. 0.001. Okay. Very good. 0.001. A little dark in the shop here. Okay. 0.001. Now, do those holes stay open? Looks like the lower one did. Maybe not. There we go. Push the lead through. The other one. There we are, both in the right spot. Whoops. Watch out for all these wires. Don't get careless. Make yourself a whole pile of work. There we go. So that's all the big bad capacitors except these two guys, these weird guys, which I was looking at yesterday. That's the power switch. That's the power coming in. These capacitors are almost certainly across the power line. And this thing floating here in the middle just still doesn't make any sense to me at all. Can we see that on the power supply? Can we see something like this on the power supply? Schematic. Let's take a jump there. What we're looking for are some capacitors pretty much across the power line here. There's that thing. They do appear to be right across the power line. No, there's nothing here. That thing, that's a wire to ground. about that? It's going to ground, it's just one capacitor. Well, it's an odd arrangement. This schematic is not, you know what, it's in the power supply. Well, this is kind of interesting. It's in the power supply, and I'm looking at an export radio on my bench. This is not the export power supply. See, 227 volts coming out of this? Oh, that could be, you could do that. What am I talking about? That doesn't mean anything. But anyway, yeah, 220. Showing this as the, I guess it would be the European setting. What's all this out here? I'll be showing you how to do something with the well, that's very odd. So this looks like some kind of test they're doing. These are test points I saw on the radio, A, B, and C. Oh, there, it's the constructor son of Chrono. That's what it is. Okay, not to get too distracted here. We don't know what those capacitors are. Just leave them alone. They don't seem to make sense. I don't think they're doing anything significant, and I'm going to gamble they're not shorted. Very, very small gamble. Next step. Fire this radio up and see what comes out of it. I think at this point, is there anything else here I should be... Oh, there's a bunch over here. So these are related to the volume control. Oh man, there's 3 of them tucked in here. I'm going to leave those for now too, because I don't think they're dangerous or, you know, critical. So let me get this radio set up to go. Okay, we're just about ready here. Got the speakers plugged in, got a power cord hooked up. No antenna, but I'm not too concerned about that right now. Let's just get familiar with the controls here, in particular the volume control. Which one's that? Is this the volume? Or is this? This has got to be the volume. Volume down. This will be tuning. Put this right there. Just there's some live wires up here. Maybe if I'm not looking, I'm going to find them. That hang like that. Okay, don't have the can on here. Is that? I'm not going to worry about that. This is a question of whether this guy works at all. That's really what we're finding out. So we're going to want to start it up with a bit of a reduced voltage here to start. And I'll also incorporate the dim light bulbs too, because they did a lot of capacitors, don't know what's happened here. Okay, deep breath. Switch it off. Okay, so the unit is off. Buttons are kind of working. This is hanging where we don't want it hanging. That's the antenna for FM. Just hang it out here. Okay, yeah, I'm a little nervous on this. For sure. Again, volume down, switches off, and we'll plug it in. Oh. Okay, I think we're ready now. Yeah, back up a step. Back up, everybody, back up. Okay, nothing should happen when I do this, we should see no light in the bulbs. Nothing should happen. And we should see, oh, something's happening. No, that's okay. I'm mistaken. Nothing's happening. No light came on. That's perfect. That means the on-off switch is off. And we're sending it about 60 volts. Okay, power off. I'm going through the dim bulb still. Now we're going to turn it on to the AM radio because its antenna's here. So this time I hit the switch, the light bulbs should come on, and should come on bright and then dull down a bit. If that happens, we're pretty good to go. If the lights come on really bright, we're in big trouble. Here we go. No lights. There's no lights. There's no light. 75 volts going over here, and it did not come on. Well, here we go. Why didn't it come on? It could simply be the power cord is poorly plugged in the back. Could be there's a fuse in here that's blown. Why don't we start with the, and we don't even know if this light works here. So we could be fooled by this light not coming on. Am I fooled right now? These tubes have lit up. It's only 70 volts, so that's really not very much at all. The radio could be half working. I wouldn't even know it. But I think there is, well, we can find out here. There's some current flowing. There's a small voltage drop on those light bulbs. I'm going to throw a switch here, eliminate the voltage drop. If you watch a meter here, I never ever show anybody. You can see it. This one here, this is showing a percentage, 0 to 100% of available voltage, or 120 volts rather. So when I hit the switch up, if this goes up, we know this thing's taking power. It went up. This guy is definitely taking some power. You can see the tube is lighting down here. The heater's on. Okay, we're cooking with a small amount of gas at this point. We need more gas on this guy. So what I'm going to do now, I'm going to put the meter like this. I'm kind of blocking the view here and there. I'm going to switch this to current. Oh, what happened? Something just fall over? I think that's all that happened. Something fell over. There's the current flow. I'm going to raise the supply voltage here. And watch the current. No problem. Okay, back to here. Put the supply voltage up. Way up. Very close to 120 now. We can read power with this guy too. Yeah. Yes, if it's set to 120, then you can read the power. So I hear tubes clicking, clinking away down below me. That's just fine. If this were 120 volts, this would be 175 all the way down to here. Just under 50 watts. So it's right in the right range. Right in the right range. Well, let's hear something. We should hear something at this point. Tubes are lit. 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 They're all lit. Turn the volume up, Jim. Ooh. Doesn't that sound? That sounds pretty scary. Don't like that at all. It sounds like, to me, that sounds like DC going through the volume control. Okay, so that's possible with all those bad capacitors. Now, can we get anything out of it? Can we get anything out of it? What are the chances? Oh! Hey, the light, hey, fix the light. I fixed the light. Hey, there is something there. There we are. That's enough. that's enough. We've seen enough. We have seen enough. We have seen and heard enough. Seen and heard enough. Now, the anything gets stupidly hot. How about this big resistor over here? Burn my finger off? No, not hot. Okay, 2 thumbs up. I heard radio signals from the antenna coming out the speaker, pretty sure. So that bodes really well. That means everything is kind of intact. May not be running 100%, but good show. So I've got another, that's scary, electrolytic capacitor down here to do, a couple more non-electrolytic ones underneath. And at that point, we'll try to really make this radio work. But that's it for now. So thanks a lot for watching, and hope you have a nice day like I'm going to have.